What if the roads we drive on could power the cities we live in? What if highways, sidewalks, and parking lots could quietly generate electricity every time the sun shines, without a single solar panel on a roof? That future isn't decades away, it's already happening. Engineers and researchers around the world are developing a technology known as solar asphalt, road surfaces that produce electricity by harnessing solar energy built directly into the pavement. And while it sounds like science fiction, the first solar roads have already been tested in countries like France, the Netherlands, China, and the United States. So how does it actually work? Instead of standard asphalt, solar roads use specially designed surface modules that contain ultra-durable photovoltaic cells. These solar panels are covered with a protective layer of tempered glass or industrial polymer that's engineered to handle the weight of vehicles, the wear of weather, and the test of time. They're textured to prevent slipping, resistant to scratching and cracking, and built to function like normal roads in every other way, except that they generate electricity when exposed to sunlight. That power can be sent directly into the grid to run streetlights, charge electric vehicles, power nearby buildings, or feed into the broader energy system. One of the first large-scale projects was Wattway, built in France in 2016. The pilot road stretched just over 1 kilometer and was equipped with embedded solar panels designed to produce clean energy throughout the year. In its first year, the road generated about 150,000 kilowatt-hours, enough to power streetlights for a small town. But the project wasn't without issues. Over time, performance dropped due to dirt buildup, microcracks, and wear from heavy vehicles. Some sections even stopped functioning entirely. The biggest problem? Cost. That 1 kilometer of solar asphalt cost over 5 million euros to install, far more than a traditional road and not yet economically viable at scale. In the Netherlands, a project called Solar Road tested solar modules built into bike paths near Amsterdam. The results were more promising. A short stretch of solar bike lane produced roughly 7,000 kilowatt hours per year, enough to power several homes or multiple electric vehicle chargers. In China, a 1-kilometer solar highway was constructed using transparent concrete and solar panels underneath the road surface. Engineers there experimented with integrating LED signage and wireless charging systems into the pavement itself. Despite the hype, solar asphalt still faces major challenges. The biggest issues are cost, durability, and efficiency. Roads are exposed to far more physical abuse than rooftops or solar farms. Constant pressure from heavy vehicles, temperature swings, snow, ice, salt, and grime all reduce efficiency over time. If the surface becomes dirty or scratched, the solar output drops significantly, and the protective materials used to make the road safe and strong also block some of the sunlight, further limiting how much power can be produced. That said, the idea is still incredibly powerful. We already pave enormous amounts of land that sit under open sky all day. If we could turn even a fraction of our roads into energy producers, the impact could be massive. That's why researchers and companies continue refining solar asphalt to make it tougher, cheaper, and more efficient. Within the next 10 to 15 years, we're likely to see more real-world deployments, especially on bike lanes, walkways, parking lots, and private roads where the wear and tear is more manageable. By 2040, if manufacturing costs come down and performance improves, we could see solar roads contributing meaningful amounts of electricity in smart cities worldwide. The promise of solar asphalt is not just about generating power. It's about redefining infrastructure. Roads that don't just connect cities, but help power them. Asphalt that doesn't just lie there, but actively contributes to energy independence. And a future where clean energy is harvested from every step we take and every mile we drive. So the next time you're stuck in traffic or walking across a parking lot, look down. That surface might be more than just pavement. It might be part of the next energy revolution. For more videos, subscribe our channel and share this video.